Hello everyone, this is the answer to this week's question of the week. I hope you've given it a shot, and if you haven't, please pause the video now and do give it an attempt. It is quite a tough question, but there is a systematic process to working these out, and I will be revealing that now. So, as we look at the question at a glance, it seems like this is a sequence question where they're going to give us a sequence of values and we have to work out the next one, but it's actually quite different. So if we read, it says the nth term of the sequence is given by an squared plus bn, where a and b are integers. Okay, so we have a algebraic sequence, and they actually haven't told us what a and b are. And then it tells us the second term of the sequence is minus 2. So the second term is minus 2. And the fourth term is 12. Okay. And the question is actually asking us to find the sixth term of the sequence. Okay. So usually if they gave us a sequence, even an algebraic sequence, where there weren't any more than one letter, usually the n, then we would just be able to plug the 6 directly in and identify what that term would be. But in this case, they haven't told us what a and b are. And so our first step to working this question out is identify a and b. And once we've identified that, plug them into the original sequence, and then plug 6 into the sequence. And then that will allow us to identify what the sixth term of the sequence is. So if we go with step 1, how do we actually identify what a and b are? Well, usually in any GCSE question, a very good rule of thumb is that they're usually going to require you to use all of the information in the stem. And so a good instinct that we can have here is that this information is probably going to be relevant. So it tells us the second term of the sequence is minus 2. So if we try to incorporate that algebraically, the second term, which is represented by n, so a times 2 squared plus b times 2 is equal to minus 2, is what they've told us. And so if we simplify that, that gives us 2 to the power of 2 is 4, so 4a plus 2b is equal to minus 2. And then if we take the second part of that, so it tells us the fourth term, so a times 4 to the power of 2 plus b times 4 is equal to 12. And again, if we simplify that, that's going to give us 16a plus 4b is equal to 12. And so now what we realize is we have two unknowns and two equations, which means that we can solve these simultaneously and work out what both of them are. Okay, so looking at these two equations, the best way of identifying them would probably be doing elimination. The other way you could do it is substitution, of course. So if we double this one, meaning that we're going to multiply both sides by 2, then that's going to leave us with 8a plus 4b is equal to minus 4. And if we see that this one is 16a plus 4b is equal to 12, by doubling it, we're allowing this term to be equal to this term. So now that they're both 4b's, another thing that you could have done is you could have multiplied it by 4 so that these two are equal. So since we have both of these as equal, we can now subtract the two equations. And you have to be very careful when you're doing these because the signs can make things a bit confusing. So we're going to try to subtract 2 from 1. So we're going to go with 16a plus 4b minus 8a minus 4b is equal to 12, and here's the tricky one, minus 4, not just minus 4. And so if we resolve this, we obviously expected the 4b's to cancel each other out, but then if we add these two together, then subtracting them will give us 8a is equal to 16, and therefore a is equal to 2. And now that we've worked out what a is, we can plug that into one of our equations. This one looks slightly easier, so I'll plug that into there. So if I plug in an a is 2, I've got 4 times 2 plus 2b is equal to minus 2. And so that's going to give me 8 plus 2b is equal to minus 2. And if I move the 8 over, i.e. subtract 8 on both sides, then I'm going to get 8b is equal to minus 2 minus 8, which is going to be 2b is equal to minus 10. And if I divide by 2 on both sides, that's going to give me b as being equal to minus 5. Okay, so I've worked out what a is and I've worked out what b is. So I can now say that I've tackled the first step of that, and that's actually the most difficult step. The next thing we can do is we can plug that into the original sequence. So 2n squared minus 5n, because a is 2 and b is minus 5. And then we plug 6 into the sequence. So now we plug 6 in as n, so 2 times 6 squared minus 5 times 6. And that's going to give us 36 times 2 minus 30. 36 times 2 is 72. So if we subtract 30 from that, that gives us a 42. So that's your answer. It is quite tricky and there are quite a lot of steps involved. So do be very careful when you're answering this. Make sure that you check all your previous steps to make sure you haven't made any errors. And just think about whether it makes sense. So if we look at the sequence, the second term is minus 2. The fourth term is 12. We're probably expecting the sixth term to be larger. And indeed, we do get a larger answer. So we can say that we're safely sure of our answer here. Okay, well done to everyone who got that right, and I'll see you for next week's question of the week.